I'm going to be solving quadratics using the square root method, but we're only going to focus on the real solutions. Let's just do a recap before we start example 1. So a recap is for a quadratic in standard form, we have ax squared plus bx plus c is equal to 0, where a, b, and c are numbers. C is my constant. So if I look at my first example, I notice that I have constants on either side of the equal sign. So I want to make sure that, and I'm missing a b term because I don't see an n that does not have the exponent attached to it. Oh, before I forget also, I also want to recap inverses. So if you have a plus sign and you want to get rid of it, you want to undo it, you subtract. If you're multiplying and you want to undo, you divide. This time we have a square. So if we want to undo that square, we're going to have to square root. You need to make sure you understand inverses because that's going to be very helpful when we're using the square root method. So let's go ahead and get started. Order does matter. What we want to do first is get rid of our constant by taking the inverse. So we had a plus sign, we now have a minus sign. What we do to one side of the equation, we do to the other. Our whole goal is to get n by itself. So we're just going to keep taking things away until that happens. So once I subtract on this side, it's 448. Now what I want to do is divide both sides by 8. Why? Because 8 next to an n squared means 8 times. The inverse of times is what I just showed you, is division. So if I divide 8 on one side, I want to divide 8 on the other side. We're slowly getting n by itself, but it's not there yet. So n squared is equal to, and then we're going to take 448 and divide it by 8, which is going to give us 56. In order to get rid of that square, like I said, we have to take the inverse, which is square root. So I'm going to square root this side. And on this side, in addition to doing the square root, because I have an exponent that says 2, I'm going to have two answers, a plus and a minus one. The whole purpose of taking the inverse is to get rid of something. So you'll see that I'm scratching things out because I'm getting rid of it. So now I'm bringing the n down and I'm left with plus or minus. And then I want to see whether or not I can further simplify that 56, meaning if I have a perfect square in there, and I know that I do, I can take the square root of 4 and the square root of 14 because 14 times 4 is 56. So now if I took that square root of 4, that gives me 2 because 2 times 2 is 4. I'm looking for a pair of the same numbers to come out of the radical. If I can't find a pair, so like here, yes, I have 7 times 2, and I also have 1 times 14, but that's not the same number as a pair. So if I can't do that, then I have to leave that number under the radical. So my final answer is plus or minus 2 radical 14, which can be written as 2 radical 14 and negative 2 radical 14. I just put it together. All right, it means the same thing. So n would equal both of those. When you're solving, you want to look at your exponent. That tells you how many answers you're going to have. All right, so for example 2, we no longer have a constant behind our squared expression. We now have a constant on the side by itself, and then we have a number that's in front of our expression that's squared. So we have to get rid of the number that's in front. Again, I am multiplying. So the inverse of multiplying is to divide. What I do to one side, I do to the other. That leaves me with x, the quantity of x minus 1 squared is equal to 8 divided by 4 is 2. You always want to simplify. Now, in this one, you see it's in parentheses, this expression, just visualize it as x squared. What would you have done? You would have taken the square root, right? So guess what? You're going to do the same thing with this entire expression. What you do to one side, you do to the other. However, you always have to remember to add a plus or minus on the opposite side. So now I'm going to get rid of something because I took the inverse and now bring down what's left over. I can drop the parentheses. I don't need them. Plus or minus square root of 2 or radical 2, however you want to say it. Now, what I usually tell my students to do is take this number, including the sign, move it directly in front, and then you want to change that sign, because anytime you go from the left to the right or on the opposite side of the equation of the equal sign, you want to change the sign. So, excuse me, that's going to be x is equal to 1 plus or minus radical 2. And notice I kept it as radical 2 because there's not anything I can multiply to give me a pair. I mean, it's not 1 times 1, it's not 2 times 2. It's a prime number, so I can't multiply by anything else. So this is my final answer. Again, it can be written as 1 plus radical 2 or 1 minus radical 2. But it's accepted if you just write it together like that. Moving on to example 3. This time I have a fraction. So we're going to have to do something with that. But before we do, we have this constant that has come back. We have to get rid of that. Order matters. So what we're going to do is take the inverse. Subtract 2, subtract 2. That gets rid of it. That's why I scratched it out. 1/2 times the quantity of x plus 4 squared is equal to 10 minus 2, which is 8. And now, in order to get rid of this fraction, I have to multiply both sides by the reciprocal. The reciprocal just means I'm flipping the numerator and the denominator. So this is really 2 over 1 and times 2 over 1, or I could just say 2. And the reason I'm doing that is because diagonally, now I can get rid of the 2's as well as the 1. And so I'm left with x plus 4, the quantity of x plus 4, raised to the second power is equal to 8 times 2 divided by 1, which is simply 16. I'm in this situation again where I have an expression that's squared, which is just like x squared. I'm just going to take the square root of it. So if I take the square root of this side, on the other side, don't forget, plus or minus square root, I'm getting rid of the radical on the left-hand side, and I'm bringing down what is under it. Plus or minus. Now, this one, square root of 16 is a perfect square. 4 times 4 is that the factors that I can multiply to give me that 16. So I can simply bring out a 4. So again, using the strategy I teach my students, take the number, put it directly in front of the plus or minus, and change the sign. So instead of a plus 4, it's now going to be x is equal to negative 4 plus or minus 4. Do not stop there. This is a common error. What I want you to do now is take this number that's out in front of the plus or minus and write it down 2 times. Now, you have one that's going to be plus and one that's going to be minus. And then the number that's after it, just bring that down 2 times. Go ahead and simplify. So negative 4 plus 4 is 0. Negative 4 plus negative 4 is negative 8. Guess what? You just found 2 answers. Either way that I'm going to write it is acceptable. So x equals 0 or x equals negative 8. That's one way. Or you can say x is equal to the set of 0 and negative 8. Typically, you would write it in the order from lowest to greatest, but it's fine. So either one of these is acceptable. And the last example. This time it does not have a number out front and it does not have a constant. So I can immediately look at this as x squared because it's all in parentheses. I'm sorry. The expression is all in parentheses. So if I saw that, I would just know to take the square root immediately. So I'm going to take the square root plus or minus square root. And now I'm left with what was under the radical. 4x minus 5 is equal to plus or minus. There's nothing that I can multiply by itself to give me 30. So I'm just going to leave it as the square root of 30. Now I'm going to take this number and I'm going to move it out front of my plus or minus, and I'm going to change the sign because I'm crossing over the equal sign. Bringing down the 4x because that's what's left. 5 plus or minus square root of 30. And now I notice x is not by itself. In order to get it by itself, I have to divide both sides by 4. So sometimes you'll see an answer that looks like this. I don't like to leave it that way. So we're going to keep going. So in my case, and I forgot no, I didn't. All right, so x is equal to 5 plus or minus radical 30. And then I'm just going to separate the fractions. The 5 is divided by 4. I was going to say one fraction is divided by 4, and so is the other side. So I can't further simplify this, so this is my final answer. Again, I could take those apart, and I could just have the 5 over 4 plus radical 30 over 4, and the 5 over 4 minus radical 30 over 4. It means the same thing. So x could be the set of that. All right, you have just learned how to solve quadratics using square roots. I hope you liked the video. Go ahead and thumbs up and subscribe. Have an awesome one.